In question number 7, two particles are moving with constant velocities on a large plane. The separation L between them and time graph is shown in figure. Value of slope dl by dt at time 25 t naught by 18 is 6 meter per second. Value of t naught is 5 by n second. Find the value of n. So it is given in the question that at t equal to 0, the separation between the two particles is 25, and at time t naught, the separation between them is 7. So let this is particle A and this is particle B. Let the relative velocity of A with respect to B is in this direction, and it is moving with relative velocity Vr with respect to B. So at t equal to 0, the separation between them is 25, and at time t naught, when the particle A is at the minimum separation from B, then the separation between them is 7. Let this separation is 7, and this is the perpendicular. So we can say that if this is 25, this is 7, then this separation can be found out, and this separation can be calculated as 24. So at time 25 by 18 t naught, the value of slope dl by dt is 6 meter per second. So we can say that relative velocity into time interval t naught is equal to 24. So if at time interval of 25 t naught by 18, let the particle A is at this position and this is B. So at that instant, this is separation L between them, and it is given in the question dl by dt at this moment is 6 meter per second. So the relative velocity is in this direction at that moment. So if I calculate this separation, then this separation would be Vr into 25 by 18 t naught minus t naught. So this is equal to 7 by 18 into Vr t naught, and the value of Vr t naught is 24. So if I solve this, it comes out to be 28 by 3 meter. So this separation is 28 by 3. So if I assume let this angle is theta, then the component of Vr in this direction, if I drop a perpendicular, then this will be Vr cos theta, and it is equal to dl by dt. So dl by dt is equal to Vr into cos theta. Now first of all I have to calculate what is the angle theta. So tan theta can be written as perpendicular, that is 7, divided by base, that is 28 by 3. So it comes out to be 3 by 4, and the value of theta from here is 37 degree. So if I substitute the value of dl by dt, that is 6, it is equal to Vr into cos 37 degree. So the value of cos 37 degree is 4 by 5. So from here the value of Vr comes out to be 15 by 2 meter per second. So if I substitute the value of Vr in this equation, then 15 by 2 into t naught, and the value of t naught is n by 5, is equal to 24. So on solving this, it gets 3. The value of n comes out to be 60. So the correct answer for question number 7 is 60. Let's move to question number 8. In question number 8, the system shown in the figure is in equilibrium and at rest. The spring and string are massless. Now the string connecting block A and B is cut. Relative acceleration of block A with respect to B is x meter per second square just after the string is cut. Find the value of x. So if I draw the free body diagram in the equilibrium position, then 3 mg is acting in this direction, and the value of tension in the string is 3 mg. The same tension is acting on this 3 mg. Its own weight is mg. So we can say that the spring force will be 4 mg. And this is the forces at the equilibrium position. So this is the free body diagram at equilibrium. Now the string is cut. So when the string is cut, the acceleration of B will be g into minus j cap. And if I see the forces acting on block A, then its own weight is mg, and the spring force acting on the block M at that moment will remain same, that is 4 mg. So the acceleration of block A at that moment can be written as 4 mg minus mg, that is 3 mg, divided by mass, that is m, that is equal to 3g, and it is j cap. So the relative acceleration of block A with respect to B will be 4g into j cap. So it is given in the question x meter per second square. So if I substitute the value of g, then it comes out to be 40 j cap meter per second square. So on comparison, we can say that the value of x is equal to 40. So the correct answer for question number 8 is 40. Let's move to question number 9. In question number 9, a uniform chain of length pi r by 2 rests on a smooth sphere of radius r such that one end of the chain is at the top of the sphere. Initially, chain is held stationary. If the chain is just released, then the acceleration of change is found to be a naught. Find the value of pi a naught in meter per second square. So at this moment, if I consider an element at an angle phi of length rd phi, suppose this is the element, then the mass of this element dm can be written as linear mass density, let it is lambda into length, that is r into d phi. So the component of the gravitational force acting tangentially is dm into g into cos phi, and due to this component it is gaining acceleration in tangential direction. So if I integrate the tangential component of force on each element at this moment and divide by the mass of the chain, then I will get the acceleration of the chain at this moment. So first of all, my task is to calculate what is the net tangential force acting on the chain at this moment. So net tangential force, if I calculate, this is equal to integration of dm into g cos phi. So dm is lambda into r into g into cos phi d phi, and the phi varies from 0 to pi by 2. This is the net tangential force, and this net tangential force at this moment must be equal to mass of the chain, that is lambda into pi r by 2 into acceleration a naught. So if I calculate the acceleration a naught from this equation, the value of a naught comes out to be 2g by pi, or from here I can calculate the value of pi into a naught, that is 2g. On substituting the value of g, it comes out to be 20. So the value of pi a naught is 20. So correct answer for question number 9 is 20. Let's move to question number 10. In question number 10, the force acting on a particle of mass m as a function of time t is given as ft equal to a into e to the power minus kt, where the value of k is 0.3 per second. The measurement of a has an error of 1%, and time is measured with a stopwatch having least count 0.1 second. The percentage error in measurement of value of ft at time t equal to 3 seconds is x%. Then find the value of 3x. So ft is equal to a into e to the power minus kt is given. So if I write the formula of propagation of error, then I can say del f upon f is equal to del a upon a plus k times delta t. So I have to calculate this error in terms of percentage. So if I multiply it by 100, this is also multiplied by 100. So it is given in the question, the percentage error in the measurement of f is x%. So this is x, and it is equal to the percentage error in measurement of a is 1% plus the value of k is 0.3 into delta t, the least count is 0.1 into 100. So from here, the value of x comes out to be 4%. So we have to find out the value of 3x. So the value of 3x is equal to 12. So the correct answer for question number 10 is 12. Let's move to question number 11. In question number 11, for the system shown in figure, horizontal surface is smooth. Acceleration of block placed on the horizontal surface is 8g by n. Find the value of n. So it is given in this. So it is given in the question. This surface is smooth and it is horizontal. So if the system is released from rest, let the acceleration of this is a in this direction. If the acceleration of this is a, then the acceleration of this pulley is also a because of the constraint of this string. And if I let assume this pulley is P and the acceleration of 2m with respect to pulley is B. B is the acceleration of mass 2m with respect to pulley P. So if I write the free body diagram, then 2mg is acting in this direction, let tension T is acting in this direction, and the acceleration of 2m with respect to inertial frame in this direction will be B plus A. Let this is the inertial frame, and if I write the free body diagram on this, mg is acting in this direction, T is acting in this direction, let this block is moving upward with respect to the inertial frame, then the acceleration of this would be B minus A. So tension T is here. Let the tension in this string is T dash, and here is also T dash. So I can say that T dash is equal to mass into acceleration. That is the first equation. If I write F equal to ma on massless pulley P, then we can say that T dash is equal to 2T. This is my equation 2. So from here we can say that the value of T is equal to ma by 2. This is my equation, let 3. So if I write the equation on 2m block, then I can write 2mg minus T is equal to 2m into B plus A. This is my equation 4. And if I write F equal to ma on this block, then I can say that T minus mg is equal to mass into acceleration, that is B minus A. So this is my equation 5. So on solving equation 3, 4 and 5, I will get the value of A, and A comes out to be 8g by 11. So on comparison, the value of n comes out to be 11. So the correct answer for question number 11 is 11. Let's move to question number 12. In question number 12, a fireman fires his shot aiming to monkey M, who falls at the time of shot. At the instant shot as passes its highest position, it is located on line x equal to 8 meter. The monkey is located at position 12, n by 3. Find the value of n, coordinates are in meter. So at t equal to 0, when the fireman fires a shot aiming to monkey, at that moment we can calculate this angle theta with the horizontal. So if this angle is theta, then I can say that tan theta is equal to perpendicular, that is 16 divided by base. So it comes out to be 4 by 3. So from here the value of theta comes out to be 53 degree. Now it is given in the question, at the instant shot has passed its highest position. Now it is given in the question, at the instant shot has passes its highest position, it is located on line x equal to 8 meter. So it is x equal to 8. So if I consider this as my range, then this will be r by 2, and this r by 2 must be equal to 8. So if I substitute the value of range, suppose the initial velocity of shot is u. So if I substitute the formula of range, that is u square sine 2 theta by g divided by 2, and this is equal to 8. So on solving, it comes out to be u square into 2 sine theta cos theta divided by 2g, and this is equal to 8. So 2 gets cancelled out. So from here, if I substitute the value of sine theta and cos theta, so sine 53 degree is 4 by 5 and cos 53 degree is 3 by 5 is equal to 8 into 10. So on solving this, you will get the value of u, and u comes out to be 10 into root of 5 by 3 meter per second. Now in the time interval, when the shot moves from this position to this position, the monkey moves from this position to this position, and it is given in the question, this value y coordinate is n by 3 at that moment. So I can say that 16 minus half into g into t square is equal to n by 3. Now I have to calculate the value of t. So in order to calculate the value of t, if I take the horizontal component of the shot at t equal to 0, that is u cos theta into t must be equal to 8. So on substituting the value of u, that is 10 into root 5 by 3 into cos theta, that is cos 53 degree, that is 3 by 5 into t is equal to 8. So on solving, the value of t square comes out to be 16 by 15. So if I substitute the value of t square, then 16 minus 5 into 16 by 15 is equal to n by 3. So on further solving, 16 into 2 by 3 is equal to n by 3. So from here, the value of n comes out to be 32. So the correct answer for question number 12 is 32. Let's move to question number 13. In question number 13, a block starts sliding down from the top of an inclined plane of inclination theta with the horizontal. Height of incline is equal to h tan theta. The coefficient of friction between the block and the surface is 1 by root 3. If angle theta is varied, keeping base h fixed so that the time of sliding is least, then the acceleration of block for that angle is 2g by root n. Find the value of n. So let's analyze the situation. Let this the inclined plane, and this inclined plane makes an angle theta with the horizontal, and it is given in the question the height of this inclined plane is h tan theta. So from here we can analyze, this is h and this is theta. So this length would be h sec theta. So if I release the block from the top, then mg sin theta will act in this direction, and frictional force mu mg cos theta will act in this direction. So the acceleration of the block down the plane will be g into sin theta minus mu cos theta. And for a given theta, this acceleration is constant. So we can say that h sec theta is equal to ut, that is 0 into t plus half into a, that is g sin theta minus mu cos theta, that is the acceleration, into t square. So from here, the value of t square comes out to be 2h sec theta divided by g into sin theta minus mu cos theta. Now it is given in the question, the time of sliding is least for a given theta. So if I differentiate this with respect to theta and substitute dt by d theta is equal to 0, then we will find that the condition of minimum time will come out when tan 2 theta is equal to minus 1 by mu. And it is given in the question, the value of mu is 1 by root 3. So it is equal to minus root 3. So from here, the value of theta comes out to be 60 degree. So if I calculate the value of the acceleration at this angle, then this acceleration is equal to g into sin 60 degree, that is root 3 by 2 minus mu, that is 1 by root 3, into cos 60 degree, that is 1 by 2. So if I further solve this, this is equal to g divided by 2 root 3 into 3 minus 1, that is 2. So it is equal to g by root 3. And if I compare this acceleration with 2g by under root n, then the value of n comes out to be 12. So the correct answer for question number 13 is 12. Let's move to question number 14. In question number 14, a particle is moving in a circle of radius r is equal to root 3 meter with constant speed v is equal to root 3 meter per second. Average acceleration of particle as it covers 1/3 of circumference is n by 4 pi meter per second square. Find the value of n. So let's analyze the situation. Let this is a circle, and particle is moving in this circle with a constant speed. Let at t equal to 0, the particle is at this position at t equal to 0, and at the moment when the particle has covers 1/3 of circumference, it means it has covered this angle 120 degree and this angle will be if I say this is equal to theta, then theta is equal to 60 degree. So at this moment, at this time, the particle has reached to this position. Its speed is v, that is constant. So I have to calculate average acceleration. So the average acceleration is equal to v final minus v initial divided by that time interval. So if I calculate the magnitude, then the magnitude of this. So the final velocity is in this direction and the initial velocity is in this direction. So if I check this vector v final plus of minus v initial, then we can say that if v initial is in this direction, then minus v initial is in this direction. So if I superimpose this vector at this position, then minus v initial is in this direction, then this angle is also theta. So if I calculate the magnitude of summation of these two vectors, since v is constant, it is equal to 2v cos theta by 2, and the value of theta is equal to 60 degree. So it is equal to 2 into v, that is root 3, into cos 30 degree, and the value of cos 30 degree is root 3 by 2. So it is equal to 3. If I calculate the time interval, then the time interval t is equal to capital T by 3, and the value of capital T is equal to 2 pi r divided by v. Since the value of r and v are same, so it gets cancelled out. So the value of small t is equal to 2 pi by 3. So if I substitute this value here, so this is equal to 3 divided by 2 pi by 3. So it is equal to 9 by 2 pi. So if I compare this acceleration with the given acceleration, that is n divided by 4 pi, then the value of n comes out to be 18. So the correct answer for question number 14 is 18. Let's move to the first paragraph containing question number 15 and 16.